Greetings everyone! Today we are going to explore solving multi-step equations, and this time we're going to have variables on both sides of the equation. For our notes this year, you should have a book of solving equations, and then we also are going to keep referencing our acronym for Don't Call Me After Midnight. Remember that when you see a pencil, that means we have something we need to write down. When you turn to page 5 of your notes, you'll notice there's a space for 3 steps, but we've actually already filled in the steps that we need. If you flip back for a moment to page 4, that has our 5 steps, so make sure that you have distribute, combine like terms, move variables, add or subtract, and multiply or divide. Your cell phone acronym of Don't Call Me After Midnight also has these 5 steps. Now, what's different today is where I have the star. Today we're going to also move variables from one side of the equation to the other. So on page 5, I don't think you need to fill in the 3 steps since we already wrote them down. Let's take a look at example 1 on page 5. As always, I recommend that you draw a line down the equal sign to create a balance equation. Step 1 is distribute. Nothing to do there. Step 2 is like terms. There's nothing on the left, there's nothing on the right that I can combine. Step 3, here's our new step today. We want to move a variable to the other side. So my option is I could kick the 5k over, or I could kick the 8k over. So technically your work can look completely different than your neighbor's, and that's okay. Is there some strategy though? Yes. I'm going to recommend that instead of a positive 5k, we subtract 5k. We're using the inverse operations. By choosing to move the smaller number, we're keeping our k value positive. Is it bad to have a negative value? Nope, not at all. Does it make things maybe a little tougher to calculate when the numbers get bigger? Possibly. Step 4, we're going to add or subtract a constant. Now, I don't want to move the -2 because then that side is empty. So here it's not about strategy, it's about keeping the scale balanced. Don't move the 2, you don't want emptiness. So you have to move the 4. -2 minus 4 is -6. The equals falls down and the 3k falls down. Step 5 is to multiply or divide. So I can see to isolate my variable, instead of times 3, we're going to divide by 3. -6 divided by 3 is -2. The equals falls down and the k falls down. Now, ideally, I would like to see the variable first and then the answer. So if you could rewrite that off to the side or below, we've got a nice clean answer. All right, we're still on page 5, example 2. I'd like you to start off by drawing a line down the equal sign. Don't call me after midnight. So one of the ways that that can be helpful is if you off to the side, don't call me after midnight. It's a reminder to distribute, combine, move variables, add or subtract, multiply or divide. So again, that's all the acronym is for, is to help you remember your steps. So first step, there's no distribution. Second step, there's no combining on the left, there's no combining on the right. Step 3 is to move a variable. All right, I have something to do there. So step 3, should I move the 2w or the 2w? Wait a second, they're the same. Now I still want to see the steps, but you already know something special is going to happen. Instead of positive 2w, we're going to minus 2w. Look what happens. So that's supposed to go away, but on the right side, it also goes away. All right, let's keep going through our steps. Normally, the negative 10 drops down, the equals falls down, the negative 9 falls down. So we're at a conundrum here. I have no letters left over. This is called a special case. So please write that, special case. So my question is this true? Is negative 9 equal to negative 10? No. So because it's false or it's not true, you have to write a specific phrase. We're going to write no solution. So if it's not true, see how that sounds negative? There's a no, it's a not. Then it's a no solution. What that means is there's no number in the world that I can plug into W that'll make this equation work. This equation's impossible to solve. All right, we're still on page 5. We're looking at example 3, and some of you are going to start to notice things already. But let's go through our acronym. There's no distributing. Combine on the left? Nope. Combine on the right? Nope. Move a variable? Yes. So let's take care of step 3. Instead of a positive 4z, we're going to minus 4z. Now, when I do that, you'll notice again, both of them cancel. But there's something different about this. So let's see what falls down. A positive 2 falls down, and a positive 2 falls down. So off to the side, please write special case. And my question to you is this true? Is this a true statement? Does 2 equal 2? Yes, it does. So we have a special answer that we are going to write. If it's true, that means we have infinitely many solutions. Infinitely many solutions. And yes, I want you to write out those 3 words. Why? Because you're going to use those 3 words in every math class you ever take. So we need to get used to saying them and spelling them. So what this answer means is I can plug in any number in the world and it'll make this equation work. I could plug in a decimal, a fraction, a whole number, pi. No matter what number I plug in, it makes the equation true. All right, now if you jump over to page 6, these 2 examples have many properties and something that's unique that we need to look at. So for this example 1, let's start here. I'm going to draw a line down the equal sign. This one's unique. I can't deal with that left side, and I need to do some steps out of order. Okay, so what that means is you'll notice this fraction bar is big. It's taking up the whole side of the problem. It's in the way. So fraction bar, I'm just going to write a little note, fills the side, right? Look how it's filling that entire left side. That's not helpful, right? So we're going to get rid of that. Well, let's see. What's the opposite of divide? Times. So we're going to multiply both sides by x minus 3. See how I took the bottom? So divide by x minus 3 and times by x minus 3 are opposites, inverses. So they're going to cancel out. All right, let's bring down what we have left over. X plus 3 equals 2 parentheses x minus 3. There, that looks normal. So let's go through. Oops, I wrote that. Don't call me after midnight. I jumped ahead a little bit there. All right, so first step, distributing. Yep, I got to distribute 2 times x and 2 times negative 3. everything else falls down. Combining, well, the left doesn't have any, the right doesn't have any, so let's cross that off. Move, yes. I need to move a variable. Should I move 1x or 2x? It doesn't matter, okay? It really does not matter. I'm going to choose to move the 1x because it's smaller. So instead of positive 1x, we're going to minus 1x. See how they're opposites? 2x minus 1x is 1x. And technically, you don't need a 1 in front. You could have one, but we also don't need it. The next step is add or subtract a constant. Yes, I do want to do that. So I can't move the 3 or it's empty, but I can move the 6 instead of minus 6 plus 6. 3 plus 6 is 9. The equals falls down. The x falls down. Hey, x is by itself. We have x equals 9. All right, let's take a look at this one. We've got a lot going on here. Don't let that throw you off by any means. Use your acronym. It's going to help you. It's going to walk you through everything. So don't call me after midnight. First rule, distribute. Yes, I need to distribute a couple of times. 1/3 of 3, meaning what's 3 divided by 3? 1/3 of 3 is 1. Okay, you can use your calculator. You can use your rules of multiplying a fraction and then putting the integer over, multiply straight across. I mean, however you remember that, but you do have to know how to do that. Subtract 1/3 of 12. Let me show that one. 1/3 of 12. 1/3 times 12 will get me 12 over 3, which is 4. So 1/3 of 12 is 4. I also have distribution here. Oops, I forgot my line down equals. There we go. 2 times x is 2x. 2 times -8 is -16. Look at that. We just did one step and everything else falls down. All right, next we have combine. Yep, we need to combine. Look at that left side. What can I combine on the left? I see a -4 and a +5. That gets me to +1. And then the 1x falls down. Let's look at the right side. Ooh, I have a lot. So let's start here. I've got 2x minus 1x. That gets me to 1x. Then I have -16, +17. That's +1. Oh, look at this, you guys. What do you notice? We can stop here. If you see the pattern, you don't have to do the rest of the steps, because what do you notice here? Everything on the left is exactly the same as everything on the right. So it's already a true statement. So if you do keep going, that's fine. You're still going to get here. But if you notice that you have the same thing on the left and the same thing on the right, you can jump ahead and you can write infinitely many solutions. All right, now I have 2 more examples. So in your notebook, just past your foldable, the next area that you have open space, I'm going to have you write these 2 examples. So please pause the video and write this example down. All right, hopefully you've paused and you've written this down. So now let's start solving. I'm going to go through my acronym. Don't call me after midnight. Distributing. Let's start there. Yep, I've got distributing to do. -2 times +2 is -4x. -2 times +4 is -8. Let's go again. Now here's something I noticed on previous homework. This is why I chose this problem. You need to distribute a -3. You got to pay attention to the sign. If you don't, it's not going to work out. Negative 3 times positive 2 is negative 6x. Negative 3 times negative 2 is positive 6. Okay, check those signs there. All right, everything else falls down because we're doing one step at a time. Next step, combine. Oh yeah, look how long those sides are. On the left, a 10x minus 1x. Technically there's a 1 there. That gets me to 9x. A positive 9 and a negative 11 combine to make a negative 2. All right, let's look at the right side. A negative 4x and a negative 6x is negative 10x. A negative 8, a positive 6 is a negative 2. Now see how I'm making those lines and curves? I just do that to stay organized and make sure that I'm using everything. Now if you want to do boxes, triangles, colors, but do something so you don't get lost in what you're combining. All right, next step, move a variable. All right, should I move 9x or negative 10x? I'm going to move the smaller one. Instead of minus 10x, I'm going to add 10x. Add 10x. On the left side, I now have 19x. And everything else falls down. Next, I want to add or subtract. Well, I don't want to move the minus 2 on the right because then it's empty. But this sounds weird. I'm going to move a minus 2 on the left. Yep, go through the steps, right? Instead of minus 2, we're going to plus 2. And here's why I needed this extra example. Yes, these go away. This is not a special case, though. Okay? Bring down. What falls down? The 19x falls down. I still have a letter. If you have a letter, you have an answer. Okay? Negative 2 plus 2 is 0. Still have a letter. Keep going. The last step is multiply or divide. Instead of times 19, we're going to divide by 19. X falls down. Sorry, it's getting a little out of space there. What's 0 divided by anything? 0. X equals 0 is my answer. Okay, if you have a letter, you have an answer. The special cases happened when all the letters disappeared. Okay, that's different. You can have 0 as an answer, so keep an eye out for that. That really does matter. All right, last one, I promise. Good job sticking with me here. If you need to pause, please do so and jot this down in your notebook. All right, let's draw a line down the equal sign. Let's go through our steps. First step, distribute. Yep, I've got to distribute here. Let's see, 5 times 13, that would be 65 with the A. 5 times 4 is positive 20. All right, everything else falls down. So now we're getting into some numbers where you might need a calculator. That's fine. Next step says combine. Let's look at the left side. Nope, nothing to do. Right side, nope, nothing to do. Move variable. Should I move the minus 5a or the 65a? I'm going to suggest that we move the 5a. It's smaller, it's easier. Instead of minus 5a, we're going to plus 5a. 65 plus 5 is 70. Whatever we didn't use falls down. Next step, add or subtract. Don't move the minus 15. You don't want an empty side. Think of a scale, right? My scale will go thoop and hit the ground. I need to balance. So I'm going to move the 20. Instead of plus 20, we're going to minus 20. That gets me to negative 35. And on the right side, the 70a falls down. Last step, we want to multiply or divide. Instead of times 70, we're going to divide by 70. Now, here is the whole reason that I chose this example. Look at that left side. That does not divide. That is a fraction that reduces. A negative divided by a positive is a negative. So let's start with the sign. And let's think about, I'm going to do a little side work here. 35, 70. What fits into both of those? Well, I know 5 does for sure. I'm just going to think this through here. Okay, so 5 fits into 35 7 times, right? 5 fits into 70 14 times. Ooh, what are you noticing? This time I'm dividing top and bottom by 7. What I'm doing here is I'm reducing the fractions. And when I reduce the fractions, I arrive at a half. Some of your calculators might help you with this as well. That's totally fine. But what I need from you is a fractional answer, and that's okay. All right, you're going to have some fractional answers in our work on our assessments. All I need you to do is reduce them if you can. All right, that's a lot of examples, but we made it through this foldable, and so we're going to keep solving equations in other ways. For today's practice, as always, check out Google Classroom. If you get stuck on anything or you forget anything, you can always come back and play this at any time. And until next time, have a good one.